Oi lads, it's Danny here today with Donny, and today what we're going to do is a tier list video where we're going to basically rank the from the easiest to the hardest physics classes. So let's get right into it, Donny.
So the first one is Introduction to Physics. Basically, it's where you explore the units of physics, so let's say newtons, and you also learn about vectors and how to connect vectors in triangles and other shapes. And this is quite simple in a way because it doesn't go into the harder levels of physics. I don't know about you, Danny, but that's what I think
Yeah,
about it.
so you're not wrong in that respect. It's where you learn scientific notation, and you also learn about tail to head method, head to tail method with the adding and subtracting of vectors. It's very rudimentary. It's not difficult, but there's a lot of new stuff that you lot have to learn. And significant figures is also something very important into that as well. So generally speaking, when you're taking it as a physics class, it's pretty straightforward. I'm gonna rank it
That's
under
super easy.
super easy.
Super easy.
Yes.
Put it there. I think it's going to be fine.
Yeah, I'm totally with you on that one, Donny.
Okay, so now it's kinematics. Kinematics 1D and 2D, which means that it follows the projectile motion. That's the first main topic. Then it goes on to circular motion.
Well, there's vertical motion, there's horizontal, well, there's a standard projectile motion, but before projectile motion, there is the vertical motion where you throw a ball up in the air and it comes back down basically from the
Yeah.
acceleration. Yeah, it's not, when you're looking at it in those topics, those early topics of kinematics, it's not difficult. It's, you play a lot with those kinematic equations, those four important ones where you're trying to find your v initial, which is velocity initial, your final velocity. But realistically speaking, they're not too difficult to learn. But I find with kinematics, when you start to move into the realms of circular motion, it could pose some difficulty. It's not very straightforward, it's a lot older. And, once you start moving more into the in-depth problems, kinematics could be quite difficult. But generally speaking, it's pretty elementary when compared to the other physics courses.
I completely agree with you, Danny, and I think it should be easy compared to the other courses we have on this list.
Yeah, so for high school physics, right? If we're basing it on that, this is what we're going to be basing it on. Generally speaking, it's not difficult. It's not difficult. So I'm going to rank it under easy. But don't kid yourself. If you're in university, or uni, right? It's kind of difficult when you get into the next level, basically. But in high school, it's not bad. Right, so let's get to the next one. Right,
Working energy.
Working energy. So, Donny, why don't you introduce this one for everybody?
Well, working energy is when you have the kinetic energy and the potential energy that's equal to the total, and it also talks about the force and how much work could be done in a force and distance manner.
Yeah, so the conservation of energy equation, where energy cannot be it could only be transformed. You cannot remove energy from the equation unless you have friction or some type of work, basically. But we also delve into what work is, basically force times distance, and it's it's some of the problems is very problem specific. Some problems could be very difficult. They provide you an image, but they could be very difficult to solve. You can have multiple objects, like a dependent motion problem where you have to use working energy. But generally speaking, some of it is very straightforward. You use a conservation of energy formula and you solve for your missing, so be it the height, the velocity, mgh for potential energy, and I believe for kinetic energy it's 1 divided by 2 mv squared. Yeah. So what would you rank this, Donny?
I think it should be easy, because the equations, sometimes the problems you usually get for this, they're kind of straightforward.
But they're very dependent on problems.
Yes.
But generally speaking, they usually tend to be easy and very straightforward ones.
Yes.
So yeah, I feel like we should move it under easy. I feel like easy's a fair critique.
Yes.
Yeah.
I think we should put in easy. Okay, now electricity topic. So we have Coulomb's law, we have circuits, and we have phasors. And all these are in combination of electricity. And we also have Gauss's law and stuff like that. Now, electricity, I would rank it personally in hard, because when you get to the harder stuff, let's say phasors and all this other stuff, and you have three-phase systems, it gets a lot trickier. And I find it should be ranked in hard or moderate, due to the fact because when you go in harder problems, it becomes a lot trickier when you have, let's say, a capacitor, you have an inductor, and you have many of these circuit elements.
Diodes as well, transistors, when you get to that, transformers. Yeah, so electricity could be quite difficult, it's not very easy. Yes, there are some simple circuits where you have an RC circuit with a resistor, a capacitor, but, when you start going into the more difficult circuits, like you said, it really is difficult to find current and find, the voltage across this resistor.
Yeah, then you have to use Thevenin's theorem and Norton's theorem, where you do the short circuit and open it, but you have to apply it to also the phasors, and you got to create phasor diagrams sometimes. And I find that should be a little bit in the hard or moderate section.
Yeah,
you agree?
And not to mention, you also use complex numbers.
Yes,
right? This is for what exactly?
For phasors and
phasors. Yeah, absolutely. And so, Coulomb's law, we didn't, and there's one more topic we didn't talk about, but the forces of electrons, right? The repellent force, the attraction force. Well, that's more straightforward, but we also have
Gauss's law.
Gauss's law, and then we got electrical fields. That, they're not very straightforward. So I feel generally speaking, this is an old topic. It's a very hard course, electricity. So I feel like we should move it into old, basically.
Yes, I believe
I agree with that. Yeah, absolutely. Magnetism now, lads.
Now, magnetism extends from electricity, and there's Ampere's law, there's Biot-Savart's law, and there's a lot of other things where you have a magnetic field, and the magnetic field is more complex than an electric field. And I find most of these problems with the magnetic field that deals with Ampere's law, we have to find the magnetic field in a cylinder or a square is a lot difficult, and I find it should be placed in hard, just like electricity. If you're going to place electricity in hard, magnetism needs to be put in hard as well.
Correct me if I'm wrong, but usually magnetism, once you touch upon those formulas and the basics of magnetism, is straight after, you go right into electromagnets, where you're using your
Faraday's law too.
Exactly, where you're using your knowledge from electricity along with your magnetism logic, and by doing so, you learn a lot about electric motors, how they work,
and motors too. You learn about motors and DC motors, alternating current motors, and it goes a lot more extreme. And I find it should be placed in hard as well with electricity.
Yeah, they go hand in hand, basically. I agree with you on that one, Johnny. So let's move that right into the hard category. Next one, waves. Can I start
this? Yes, you can start this one.
Yeah, so waves. Where do I begin with waves? So waves is one of the first classes where you learn how to read, a graph, basically, like how to find the amplitude, the wavelength, the period, the frequency. And you also learn about the sound waves, the Doppler effect, if I'm not mistaken. When you hear the sound waves, at what velocity they come, basically. It's not a very difficult course once you have the equations down and you learn them for the very first time. And this also includes simple harmonic motion as well. You get the hang of it, but it's not the easiest of classes. Once you play around with solving for the frequencies and all that, basically you start to see the trends and how to solve your standard problem, but it's not super easy, I must say.
And plus you need to know how derivatives work and integrals, because you're given that simple cos formula, then sometimes you have to convert it to acceleration and also to velocity. And I believe waves should be placed in moderate, because it is
I agree with you on that.
It's kind of straightforward, but it's not in a way.
Absolutely, certainly. Yeah, let's move that into moderate.
Optics, once you do all the problems set, it's not that difficult compared to waves, I find, because once you do all the possible scenarios of where the lens is, what's the diverging, converging, it's not that.
Convex lenses,
Yes.
concave lenses. Yeah, I'm very familiar with that. Yeah, as you know, as Donnie mentioned, it's not a difficult class. Obviously, there's a lot of geometry aspect in the class where you got to draw the rays properly so you can measure, the image on the other side of the lens, basically. But realistically speaking, once you have done a lot of examples, and the formulas are very straightforward, if I'm not mistaken, or if I remember correctly, it's not that hard. You just have to do a variety of examples, but once you have done them, it's the same problem over and over again.
Yes, and I believe it should be placed in easy because...
Yeah, I really agree with you. Let's move that into easy. Enough said about that one, basically. Now, fluid mechanics. So this is a lovely topic. We, in high school physics classes, they touch upon it very briefly, but to give you like an idea, so think of it like, the flow within within a pipe, basically. If you have a pipe with a larger diameter compared to a pipe with a lower diameter, and you got a liquid which is basically flowing from the bigger diameter to the smaller diameter, the mass flow rate is significantly different, and it's all that basically. And also, not to mention, you have your viscosity equations where you look at, in terms of how sticky is that fluid. Is it, when you also look at non-Newtonian fluids, Newtonian fluids. So generally speaking, you also got, your conservation of energy formula where you learn in working energy, but it's called the Bernoulli equation, and it looks at, the pressures and the different heights which the fluid is moving inside a pipe, let's say, or a tube. So, long story short, it's pretty. It could be easy. Yes, don't get me wrong. It could say easy, but there's some very hard components regarding
it's more
fluid.
Theoretical. Like
it's not necessarily theoretical. There's a lot of theoretical things that you have to know, but it's a lot of problem solving. And the problems could be, of a variety of different difficulties. Some of them are very easy, some of them are very hard. It really depends, basically. So I would rank it under moderate. I believe it should be moderate. There's some easy chapters in it, but on the most part, it's not super easy. So I'm going to rank it under moderate. Right, so momentum and collisions. When you play, let's say you play billiards, right? And you got your ball basically, and you're hitting it.
Yeah, you're understanding that collision.
It's the impact at which you shoot the ball at an initial velocity, it hits another ball. What's the velocity of ball A and then ball B, basically? So it's understanding what happens after a collision, and and then you got momentum, where it's basically the most simplest of form of momentum is mass times velocity. And it's not super easy, because once you get to angular momentum it's very difficult, and this is pretty hard. I'm not gonna lie, it's pretty hard, but there's some easy topics to it. But I feel like if you're considering the whole course in general, it's more on the between hard and moderate.
I would give it moderate, hard, because I'll tell you one thing about momentum and collisions. When you deal with those angular momentum problems, and they do come,
they're very difficult.
Those are very difficult, and they're very hard to understand. And I think it should be placed in hard, because you have electricity there and magnetism, which are very hard, and I think it fits well over there.
Yeah, I agree with you. I feel like we're going to move it there. So let's do that right away. Let's move it right hard. Now we're going into thermodynamics.
So thermodynamics, you learn the first law, the second law.
First law of thermodynamics.
Yes, and you learn about
entropy,
Gibbs free energy.
Q equals MC delta T.
Yes.
Their formula. There's some very easy aspects. You also have heat transfer. You also look at the an object in space, right, which gives off heat. It's an exothermic object, basically, because it gives off heat. Like, think of it like a coffee mug, right?
Yeah.
And it's giving off heat, basically. So heat transfer surrounds us. It's not a very obscure topic.
No, it's not. But I think it should be in modern, because I feel like there's some formulas they just give you. You have the right things inside the question. You just plug it inside a formula. You have to look at a chart. And some questions are like that. Some questions are a bit more abstract. But in general, I feel that thermodynamics is like that. And I believe it should be placed in moderate.
Yeah, totally. And there's also, there's also the different types of cycles. You got your refrigeration cycle, and these are not very straightforward to find. The superheated liquids, and then all these types of what's the pressure after it goes into a pump, and it's in terms of a refrigeration cycle, a Carrot cycle as well. So I feel like moderate. It's where it belongs. There's some easy aspects, but there's a lot of hard aspects as well.
It's not all of a walk in the park, if you know what I mean. So.
Right, so now we got a big one right over here, statics and dynamics. Can I start with this one first? So statics
you go right ahead.
Is the study of forces where the summation of all forces is equal to not equal to zero. And dynamics is basically when you got movement, so it's equal to mass times an acceleration.
Basically Newton's laws, right?
Newton's laws, so you got your first, second and third law, right? Okay, so this is the story with statics and dynamics. It's very hard. It's very hard because every problem is very specific, and there's some very easy statics problems. There's some very easy dynamics problems, but there are some very difficult ones.
Yes.
Some very difficult ones where you're looking at, they give you an image and you're looking at it and you're like, where do I start first? What's the first thing I should do? They're giving me a lot of pieces of information. Sometimes you're not dealing with a linear motion, you're dealing with circular motion. So you got to take a moment, you got to take a talk. And you're dealing with a moment of inertia, which is denoted as a J or an I. Instead of M times A, you got something else. You got I times A, or J times A. So
yeah,
it's not easy. It could go way difficult. It could go way easy. It really depends the level you're at. In uni, it's very difficult. In high school, they tend to go a bit more easier. But since it's so
spread out. The topic is kind of spread out. If you look at it in college level,
I find it's hard.
In college level, I would say between moderate and hard. But if you go to university level, definitely the hard and impossible category. So let's put it in hard.
Yeah, absolutely. I believe it should be in old. So the last one, I'll let Johnny to take the reins on this one.
So modern physics is basically like Einstein, quantum mechanics, time dilation, and
exactly relativity. Yeah, it's all modern physics. I believe it's after the 20th century, if I'm not mistaken. Yeah, so it's very new types. I think also quantum mechanics, quantum physics, I believe it's called. So it's very abstract stuff, if I'm not mistaken. It's not very easy to grasp.
Because you're playing with time, because you're playing with changing time, and let's say you're on a train, the time on the train is a bit different than the person watching the train.
Yeah,
and
that's relativity.
Yes,
yeah, from
and
Einstein,
that gets kind of tricky. And I find like this is impossible because even Einstein, the ones discovered it.
This is an introduction class to it. It's not in depth. It's not. The equations are not hard. It's more the theories are more abstract to understand. But the equations, calculation are very rudimentary. I find they're not difficult. I can't really see it putting it in impossible. I believe it should be something more
moderate.
Exactly, because it's an introduction class. If it was not an introduction,
university level, impossible. But is it introduction class? It should be a moderate.
Yeah, I totally agree with you. So that's basically it. So we basically ranked all the different types of physics classes. As you clearly see, we didn't put anything impossible, but there are some elements of each course which are very difficult. Especially when you look at electricity, there's some very difficult aspects, and even dynamics. Same goes for dynamics. Even go to the extent of kinematics. Any type. It depends. It's really dependent on the question, basically, to make it difficult.
It really depends on what you're talking about, because in high school level, any of these physics is kind of easy, but once you start going into the university level, and it becomes really abstract, even the easiest one, even kinematics, it becomes really hard, really fast, and I believe that I find this tier list makes sense.
Yeah, I agree with you.
If you're in the university level, most of these physics will become a lot harder, and that's it.
Yeah, totally. If you have any suggestions or you like to make any comments, please write down below. If you believe that something is old and we put it in easy, please mention why that is and give us your feedback. We like reading your comments, so we want to see, what you lot think as well, not only what we think, right?
Yeah, we like hearing other people's feedback.
Yeah, totally. So that's the end of the video, lads. A pleasure as always, and I'll see you lot in the next video. Take care and bye.